All right, we're going to continue with Unit 4, Lesson 9 with problem 9.2. What we want to do is we have three right triangles. We want to find the missing side lengths and the missing angle measures. So I'm going to start with triangle ABC. I notice that I am missing one of the side lengths. I know it's a right triangle. So that means I can use the Pythagorean theorem, and the Pythagorean theorem states that the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So I can set this up, a squared plus b squared equals c squared. Now a little bit of algebra. X squared plus 9 squared is 81 is equal to 10 squared is 100. Now I need to subtract 81 from both sides, and I get x squared is equal to 19. Now I'm going to take the square root of both sides to get the x by itself, and the square root of 19, I believe, let me get my calculator here. Square root of 19, is 4.36. So 4.36 is the length of that side. Okay. Now I need to move on, and I need to find some angle measures. Let's start with the measure of angle C. Here's the measure of angle C. A couple things we want to remember. We do definitely need technology. We're going to need a scientific calculator of some kind that has sine, cosine, and tangent on it. So make sure you have that handy. I have a graphing calculator emulator on my computer here, so I will use that. You use whatever it is you need to use. Here we're looking for the measure of angle C. What I don't like to do is when I'm looking for an angle, I don't like to use a side length that I had calculated before, because if I mess up these calculations, that will make my angle incorrect. So what I want to use is I want to use side lengths that were given to me. And here's angle C. The leg opposite angle C is the leg that's 9. And then this side that is 10 units long is the hypotenuse. So I need to somehow relate opposite and hypotenuse. I know that the sine of any angle is equal to the length of the opposite divided by the length of the hypotenuse. Now I can plug my values in. The sine of angle C is equal to the opposite, which is 9, divided by the hypotenuse, which is 10. Now what I need to do is I need to get rid of this sine. Now the nice thing is, just like subtraction undoes addition, just like division undoes multiplication, we have a function on our calculator that undoes taking the sine of an angle, and that function is called sine inverse. When we raise it to the -1 like that, we call that inverse. So what I want to do is I want to take the sine inverse of both sides. On the left-hand side, this sine inverse cancels that sine, and I'm left just with the measure of angle C is going to be equal to whatever the sine inverse of 9 over 10 is. So now what I need to do is I need to get my calculator, and I need to figure out what is sine inverse. Right here is the sine key. Notice the second function of the sine key is the sine inverse. And then I just type in my ratio of 9/10, hit enter, and it gives me a 64.15806 blah 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 angle. We're going to round our angles to the nearest degree, so we will call this one a 64-degree angle. Now that I know that the measure of angle C is 64 degrees, the measure of angle B is easy to find. And that's because I know that the two acute angles in any right triangle must sum to 90. So then the measure of angle B is going to be 90 minus 64. So then angle B will be 20 6 degrees. So there I found the missing side lengths and the missing angles from that right triangle. Okay, moving on to my second right triangle, I notice that I'm missing the hypotenuse in this case as the side length. So I know that the sum of the squares of the legs in any right triangle is equal to the square of the hypotenuse. 5 squared is 25, 6 squared is 36, that's equal to x squared. 25 and 36 feels like a 61. Now I need to figure out what is the square root of 61. .81. So then I know my x value is 7.81. So there's the missing side length. Now I need to find the missing angles. We'll try angle G here. Remember, I don't want to use the side length that I solved for. So here with angle G, I have a leg that's opposite and I have a leg that's adjacent. So remembering the SOHCAHTOA that we had talked about, I know that the tangent of any angle G in this example is equal to the length of the side opposite divided by the length of the side adjacent. So that's 6/5. Now just like we did sine inverse, we can now do tangent inverse. Apply that to both sides. The tangent inverse will cancel the tangent, and I end up with angle G is going to be equal to whatever tangent inverse of 6/5 is. So I bring out my calculator. I want to find the tangent inverse of 6/5, and I get 50 degrees. So then I know that angle G is equal to 50 degrees. Now for angle J, I remember that the acute angles in any right triangle must sum to 90. So then angle J must be whatever 90 minus 50 is. Angle J is equal to 40 degrees. Now I have found the missing side lengths and the missing angles for this triangle. Okay, on to my last triangle, triangle DEF. I notice I'm missing a leg. So I know that the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So then I can solve a little algebraic equation here. Subtract 16 from both sides. Running out of room, we'll take this up here. So x squared must be equal to 30. Now I need to take the square root of 33. So I come to my calculator and I want the square root of 33, 5.74. So my x value is 5.74. I found the missing side length. Now to go after those missing angles. Any one you want, we'll choose angle D. I know that I have the leg adjacent to angle D and the hypotenuse, and I have to remember that cosine of angle D is equal to the length of the side adjacent divided by the hypotenuse. And just like the others, in order to get angle D by itself, I am going to take the inverse cosine this time, Inverse cosine cancels the cosine. So now I have angle D is equal to whatever the inverse cosine of 4/7 is. Now I bring up my calculator. I need to find the inverse cosine of 4/7, and I get 55 degrees. So then the measure of angle D is 55 degrees. And then again, angle E and angle D must sum to 90. So then angle E is going to be whatever 90 minus 55 is. Angle E will be 90 minus 55 is 35 degrees. Now I've found the missing angles and the missing side length. So really, this is just about understanding how to use sine inverse, cosine inverse, and don't forget Pythagorean theorem to solve these triangles.